Hello, everyone, and welcome to this webinar. Apologies for the issues to log in today. It's not the usual, so my apologies to all of you. And first of all, I would like to welcome to this internal webinar on the latest enhancement in the Relion 6700 series version 227. Happy Friday, good morning, good afternoon, and good evening, depending obviously where you are located. And I think people are still joining, but we will take a minute just to familiarize with your surroundings. In case of having an emergency, that will be crucial that you know how to exit the place. And then if you are on the go, please ensure that you are in a safe location for the entire duration of this meeting. And I beg you not to put yourself or others at risk by attending this meeting. And obviously, if you are driving, please drop off the meeting now. As usual, this meeting will be recorded, so we will be sharing all the materials with you, the Q&A, the presentation, and then in the top bar, you will have all the questions and answers there. We will be sharing some questions in the middle of the presentation as well. And we'll encourage you to take part of our survey as well. And then to me, it's a pleasure and honor today to welcome our speaker here, Marco Kovac. And he's the Global Product Manager for Bay Level Products 670 series. And without further ado, I'll let the floor to you, Marco. Thank you.
Thank you. Thanks, Lourdes. So, hello, everyone. Good day, good morning, good afternoon. Yes, my name is Marko Kovacic, and I'm responsible for the 670 series in our product management team. And I will be presenting you today today's webinar. And thanks for joining this session. So, as usual, we will go first through quick recap to see first where 670 is applied, and then we will move to how it developed over years, and the way we came to today's 227, and then we will zoom into this release. We split it in two parts. So first applications, and then the base software, that is communications and cybersecurity part, and then some news around the packaging and optimizing the offering, mainly on hardware, because we had some end of life of the components. And then, of course, the tool PCM 600. I'll explain what is needed there for communication with 670.227. And then in the end, some of these support materials and in general, our user documentation certification, where you can find stuff that will be useful then for bringing the product to the market. So first on the positioning, as usually we show this kind of slides just to reiterate where we intend the usage of these products. So 670 series products, IDs, with their operational performance on the high end and software and hardware flexibility, are used on transmission, sub-transmission level, and generation. Right, so we are talking about this part over here. The product is flexible and scalable also on the hardware side. So there are three form factors with variety of modules that can be adjusted to meet the application needs. Then on the same voltage levels, mainly speaking about transmission and sub-transmission, this is where our merging unit, single box solution SAM 600 3.0 is also used for digital substation applications, and also typically on transmission and sub-transmission is where we see need for distributed busbar protection in general. So RED 500 is also used there. And then for the primary distribution segment, and then also in the future as we develop further our REF 650 offering, that's where REF 650 will be used. So primary distribution part and the industrial segment. Then we came quite a long way since 2005, now 20 years on the market with 670 series. Version 1.0 was introduced back then. It's currently obsolete. And then we moved from 670 to 1.1 all the way to 2.1. These versions are in limited life cycle status, and the only active version is 672.2. Now, we streamlined and simplified the portfolio, so 672.2 is the only active one, which means that it covers full application range of all the previous versions, and it offers something more, of course. The versions that are in the limited state, they are still available to support the installed base and existing customers for extensions and spare parts. So we don't provide them for the new projects. That's where 2.2 shall be selected. Then there has been some questions and concerns on the life cycle of 672.2. So it is important to say that 672.2 is and will remain our main transmission ID offering. Of course, you are all aware, I'm sure, that we have a new platform on the way and that we will eventually also transition with 670 to new platform, but that will happen during the time. And for the time being, we keep with 672.2. We keep maintaining it, developing it also, and its life cycle as active will not change at least until 2029. But this we will not do actually without you. So that there are two preconditions to change the life cycle of such important product with such huge footprint as 670 Series 2.2. The first one is, of course, that the new solution will be able to replace completely what 672.2 offers and offer something more. That's always the idea. And then also we need to have clear handshake with all the hubs with regards to homologation processes, approvals, and frame agreements, right? Only when that is in place, then we will switch or start considering 672.2 lifecycle status. So version 2.2 now, to take a look more closely into it, back in the summer of 2017, we brought this new version to the market, which made quite some change to what 670 used to be until then, and it made quite quick acceptance on the market because of the unique improvements of this closed box concept and conformal coating, improved IP and hardware robustness in general, and then stronger communication stack with HSR, PRP, and later also RSTP with SFPs and so on. And then roughly a year and some months on average, we were releasing a new version, increasing this third digit, right? Bringing in mainly the software improvements, application functionality, but then also, of course, the communication part, base software, cybersecurity, and also improving the hardware along the way. So the last one was 226 back in June 2023. So it's been almost 2 years that we have been doing stuff, and we have been doing this that you see here. This is quite a dense package of new functionalities and improvements where we were trying to meet the market needs, which will do then continuously, because this doesn't solve everything, as we are aware, but this is really positioning 670 better in some aspects and segments. One of them being digital substation applications with 69-9 protocol, better harmonization within the portfolio, because now SAM 3.0 and 672.2 can speak over 61.869-9. Then further, we introduce additional capabilities in digital substations, which not all of our competitors have, such as redundant merging unit support. On the security part and communications, secure MMS has been introduced. There is a bunch of interesting news around line differential communication and line differential protection. So look into that. On the protection related functionality. There is no smart reclosing capability to will see into, and then renewables also segment there with two important functions, PMU improvements, and then several other functions actually, and bug fixes, and the packaging and utility and so on. So we'll take step by step. So applications first, and first among the applications is the most important one, I would say, from the new market segments perspective, and also for existing markets, because this model-based protection is something unique, something that no other competitor has, and something that solves concrete problems in the system. Now, talking about differential protection in general, especially line differential protection, in the past, and in also in something that is like perfect situation, like the current that comes in the segment of the line will also leave that line. So according to the Kirchhoff's law for currents, the summation of these two shall be zero, right? And in conventional old systems, it used to be somewhere there, but with the grid development, with the addition of series compensation or shunt reactors, different adjacent elements like HVDC and whatnot, we observe that from actual com trades that we receive from the site, that this is no longer really the case very often. So when you have a very long line, or when you have long cable, or when you have the different load conditions, when you have a bunch of IBRs in the system, then whatever comes into the protected line will not be what comes out. So what comes in will not exactly reflect the current that is leaving the diameter. Sometimes we observe that the change of angle of the current that's entering protected line or cable can be from 30 to 180 degrees difference to the one that is leaving the line or cable. The amplitude of current can change a few hundred amps, which sounds really crazy, but this is what we observe without fault, right? These are normal operating conditions. Now, all this makes it very challenging for conventional line differential algorithm to detect fault, because you have to desensitize it. So if you have this fake differential currents due to capacitive contribution, due to changes in the voltage and so on, and the angle, you have to lift the threshold up to 100 or 150%. And then if you have fault, I mean, not really the high impedance fault, but almost any fault, then it's hard to detect it. Now, what we are doing with this protection is that we are now capable, based on this two-port model, to model the primary elements so that they are reflected in the IED, so that the IED knows exactly what is the primary topology. So where is the line and what kind of line? If you have a shunt reactor, series compensation, transformers in zone, and so on. So this can be factored in so that the IED takes its local current, and it will receive remote current as it is, twisted and distorted by all these factors, but then it will say recalculate or normalize it. It will take all these segments and all this topology into consideration, and it will be able to readjust that current so that it can remove all that negative, say, influence from changed angle, changed amplitude, and so on, and remove the capacitive charging current and calculate exactly pure differential current. This in turn means that instead of desensitizing your line differential threshold to 150 or so percent, you will be able to bring it down to around 20%. So to make it again very sensitive, and this is the key. So all of this story just to tell you that this function and enables amazing levels of sensitivity even for these applications. So these are the big news. But that's not all for line differential world, because also in RED 670 we are bringing two additional things that will help customers to resolve some concrete problems. First one is sensitive line diff element, which is basically line differential based on zero sequence currents. That is I mean, why that at all? That concept. The idea here is to tackle the problem of capacitive currents, because capacitive currents are because of the ratios of capacitive reactance, typically 1.5 times higher in direct sequence system compared to zero sequence system. So they are of less disturbance in zero sequence system, right? That's why by default you can desensitize, or rather you can pull down, you can make it more sensitive, your line differential element that works on zero sequence currents. So wherever the traditional short circuit phase-to-phase fault line differential threshold will be, this one, the sensitive one, can be even lower, right? In some good scenarios, it can go down to 10%, as we show here. Of course, there are challenges of asymmetry when you're closing or opening the breaker, or have outer closing cycles with single phase breakers, but during that time the operation of this protection can be blocked or delayed for a given time. And then short zone differential protection. So we are basically with this one adding one more line differential element in RED 670. Here, the sensitive element is incorporated in the existing high-speed line differential, L4C, right? Whereas short zone differential protection, we are basically taking the generated differential protection and bringing it into RED, not with the intention of protecting generators with RED, but instead to use it as so-called short zone protection. And what is it about? So, for example, if you have mixed line, such as here, you have like cable section. For example, in the power plant, so if you have generating plant somewhere here with generator step-up transformer, or if it's the GIS, so you're take the cable into the GIS, and then following, just connected directly to it in the series, you have the overhead line. Then you can connect the CTs from this cable section directly. You can hardwire it to the IED, and this is the intention, right? So whenever you can hardwire it, then this can be used. It can also use communications, but it's not the idea here. The idea is really to cover this cable section with this fast operating differential protection that has also very good DC handling if it's generator in the vicinity, to handle better stability for the faults outside of the zone. So when the fault happens on the cable, right, or on cable terminations or anywhere here in this diameter, so that it can trip very quickly and it can block the outer enclosure in the main line diff, so that the circuit breakers do not auto reclose on the cable, which doesn't, of course, make sense. And so that, the three-phase tripping is achieved. Also, the idea going with generator protection here, differential one, is that you can go with it like this because the compensation of capacitive currents is of no relevance, because for such short cables it's not really relevant aspect. So that's why the idea is not to connect now this one with LDCMs and cover, I don't know, few like dozens of kilometers or something, because then you have capacitive currents. So for shorter cable sections, let's say up to a few hundred meters or so, that's the idea. Then adaptive auto recloser. We have developed this function, which is then being added in the logic connected to the main auto recloser function. So this one is adaptive one, or smart auto reclosing, and then it is connected in ACT, in application configuration tool, to the main auto recloser. What it does, it can on the one hand, it can shorten the dead time because it can figure out when the fault is gone, so it's safe to reclose. And then also it can figure out when the fault is persisting, so it can block the unnecessary reclosing on the fault, and it can help the ID to issue the final three-phase trip and block the AR. How does it do that? So there are a few things, but the main one is voltage measurement on the line side. So it's for the lines, of course, and it doesn't work with the VT that is on the bus bar. So the VT has to be on the line side behind the breaker. So once the breaker opens for both line ends, the actual wire, the line, remains basically in air, right? In theory, there should be no voltage on it, even if the fault is gone, but the voltage will exist because of the capacitive coupling of the healthy phases, right? Because we are talking about single phase auto reclosure here. That voltage will be around 10% of the U base or above. Our default setting is 8%. And it will be pure DFT 50 or 60 hertz sine wave that the function measures. And then once it measures it, once everything is stable for 15 milliseconds, it will give permission to auto reclose no matter what that time is. So if that time was 5 seconds and this calculation is done within, I don't know, 20 milliseconds, it will right away send the information that the break can be reclosed, for example. On the other hand, if the fault is persisting, if the location of the fault is still arcing, this arc connects the piece of wire that is now in the air to the ground, and the voltage is zero, close to zero. So there will be no this capacitive, so to speak, voltage measured by the VT. Voltage will be very, very low, close to zero. And in that case, it will hold, right? It will wait, and it will not give permission to auto reclose. It also has additional checks like current checks. It has also current inputs. It is also measuring harmonics, which can be turned on or off, but we recommend keeping it on because when the place of the fault is still arcing, there are a bunch of harmonics that are generated there, and then this distortion can be measured by the relay. Whereas when the fault is gone and when you have this pure capacitive contribution to the voltage, it's very pure sine. Major frequency component wave. And then it also checks the angle, because this angle of this voltage that is now disconnected from the fault, it is not typical, but it's always between the two healthy phase voltages of two other phases that are remaining. So these checks, some of them are done by default, some of them can be switched on or off, but really to make sure that the conditions are stable between switching the CB back on. And then on the PMU, we also did some minor improvements, but several of them to help the customers that have this in their specifications. So there was a need to add longitude, latitude, and elevation, so that this information can also be communicated over this synchrophaser standard communication. Then on top of TCP and UDP unicast, we also added UDP multicast. Then to this PMU ID data type, we have added the possibility so that it can be entered as a free text and an integer. And then we also enable basically on our under power over power function blocks the active reactive power and power factor on the outputs, so that these values can be used as synchrophasers. These values, mainly power factor, was before available only on the measurement functions, which were 100 millisecond cycle, so it was too slow to refresh in each synchrophaser package that was sent to the client. So now this allows a bit more flexibility and refreshing the value of power factor in each package that is sent via synchrophasers. And then coming to renewables part, two really important major functions here for the point of common coupling. So 670 will be, of course, used in subtransmission and transmission, where we also see, of course, the integration of renewables connection to the grid. And on that connection point, the relays have to observe the voltage, of course. Now, the first one, directional reactive power under voltage protection. So it's quite a long name for a function that is rather simple, but important because it, in the situations of lower voltage dips on the point of common coupling and then in the grid, in that part of the grid, it is important to give time, for example, to wind parks to generate power and to inject the reactive power into the system. So because reactive power does help the voltage to pick up and to be preserved. So this function does exactly that. So it is under voltage. So once the under voltage is detected, it will start to observe the under power, or rather the reactive power direction, right? So if this direction flows towards the system from the wind park, fine. But because that helps to keep the voltage up. But if the power reverses, so if the wind park suddenly starts to consume the reactive power, then that's trouble, because that will then deteriorate voltage situation even further, and that's the time to disconnect the wind park. So that's what this function does. And then the other one that does similar thing, but really without the power directionality measurement or power at all, is the under voltage ride through protection. Yeah, also rather a long name for again simple function that is really kind of smart under voltage protection. So again, on the points where the renewables are connected to the grid, when the voltage dips, it will take some time to recover, and yeah, various grid codes do describe this, and they have definition of how this curve should look like, but it roughly follows this kind of trajectory. So when it really recovers, if it doesn't recover, if it falls back down into this trip region, then it means that perhaps because of the reactive power flow, because maybe of transformers with regulation of voltage didn't do their job. So then to de-risk the collapse of voltage further, then that part of the grid is disconnected, right? So this basically allows for more flexibility, or giving the time the system to recover the voltage. And then on a bit more simple functions, really purely voltage and current based, we have introduced this over voltage release function, the fast one, that intended to be used mainly in busbar applications. So when the voltage drops, then it can send very quickly release or start signal that can be combined with zone trip for busbar protection as additional security if needed. And then also for the current protection, now we have introduced this single phase protection, which of course, 3 instances will be used for 3-phase system. The idea is here to tackle some challenges that we see in some cases with our existing OC4 PTOC that has been around for quite a while, and it's grown over time. It has a bunch of settings, so this one is more simple. And the key difference is that the phase selection here doesn't depend on the IN that is on 3I0 level. So it doesn't care about the zero sequence current. It is using only cross polarization. This is also due to grid changing. I mean, we have observed some situations in the system where even for 110 kV grounded, directly grounded, effectively grounded system, for some earth faults, there was no zero sequence current. In such such situation, for example, this function can be of benefit. Okay, so then before jumping to this base software part, I'll just quickly check the questions. Maybe I'll go from the bottom up. So Petru is asking, currently IDs support disturbance records sample 1 kilohertz. Will the new platform support disturbance records at higher? Yes, it will. So that's for the new platform, not for this one. But it will support higher 4.8. That's I mean, you can take a look in SAM 3.0 and REF, so that what we have there is already then available. So it will be like that also for the future 670, at least in the first steps. Sergey is asking, will these new developments allow to address new market in which these functionalities were missing? Yeah, I mean, that's the idea, to address the markets where this was requested, where we had troubles entering, right? Let's see further when I come to some parts like 69-9, what is the situation there? And then from Abakash, we are seeing increasing number requirements of protection functions which consider RMS values containing higher order harmonics, 100 order, for example, but right now we have up to 9 in RMS. Is there any planning to include higher order harmonics? Yes, in the next generation, where we have, I mean, here we have basically the thing with hardware limitation as such. So for these new developments, improved RMS with higher order harmonics, we will need to use shunt technology that we have in our SAM 3.0 and REF, which will help us there. So yeah, there are definitely plans in the future for that. How can we, from Jonathan, how can we keep our customers updated to the new firmware releases? Is there a subscription option with the main differences between the versions they have versus the new released ones? Yeah, this is a good question. I mean, we have an initiative ongoing to make release notes available eventually in more accessible ways. So this is currently action on the organization on product management. So we are looking into this and we'll come back. But this is really, I mean, not to make it too diplomatic answer, but something that really we are working now proactively on with a lot of focus. Okay. Let's see then one more maybe from Pablo. Okay, I jumped a bit up, then I'll come back later to other questions. So Pablo, is the near future we can offer 2 PCMs in 670? Yeah, this will be then for the next generation as well. So in this one, we will not be able to do that, at least not what we can see so far. There was once an initiative, but we didn't pursue it. We didn't continue with it. So that one, yes, but on the next generation. So on the base software part, let's start with Ethernet-based teleprotection or Ethernet-based communication for line diff, for line protection, which is now called LDCE. This is a solution that is using the good old C3794 in the Ethernet frame. So this is not 9-2, this is not 69-9, this is C3794 in Ethernet frame. In 226, we introduced single mode SFPs that can go up to 120 kilometers or so, depending on the budget of the optical budget of the line. So now we are introducing this capability as well, mainly for differential protection, but of any kind, but also for line distance, for exchanging the binary signals, for permissive underreach, overreach, and so on. So the existing SFPs can be used here. So 670 series supports up to 6. We know already that there are some concerns because we don't plan to extend this. There are customers that are using up to 5. In that case, the 6th one, of course, can be used for LDCE, but then without redundancy, right? Still, if you can use at least 2 ports and you can achieve redundancy, you can have really nice solutions like HSR rings for multiple line ends, and also make it more cost efficient. Now, this solution on the time sync part requires PTP, but so it doesn't support this echo or ping pong method, but that's not an issue. So you don't actually need to have PTP in the station as such. You can have SNMTP or whatever there is in the station. If you need to deploy this kind of scheme, then the ports assigned for LDC communication across the line ends can run their own so-called relative PTP between them that effectively works then like ping pong method. It supports full redundancy. Of course, HSR, PRP, even RSTP is supported, but not recommended, of course, because of no zero-time switchover. So you can either use it for direct connection or also connection outside of MPLS and SDH and whatever networks through switches like this. This is something that we don't recommend because the solution is not secured, so there is no encryption, and if the customer sees that as a risk, then definitely they should move to direct point-to-point communication without switches. If switches are permitted, then this can also be, of course, used. MPLS is a big topic. In theory, this should work in any kind of MPLS network as long as there is PTP time sync. In practice, we did not test this, and there is a reason for that we didn't test it at least yet, but we are looking into some pilot projects. If you have any customers who would like to try this out in their in some pilot installations, you can reach out to me so we can check. We can provide some devices to be tried out. In the meantime, as soon as we have certain results from the pilots for IP, MPLS, MPLS TP, or what have you, then we will bring this information into the manuals. And then the idea here is that the solution is more cost effective compared to LDCM. Now, why we focus first on the direct link communication is because we have end of life situation with LDCM medium range and long range, right? And there we have sufficient amount of components to keep LDCM's medium range and long range for years to come, and also for new projects. But we are acting here ahead of time, so we are basically planning for some future. The combination of SFP plus whatever line differential protection or whatever else there might be is always cheaper because of pure hardware cost, which is reduced compared to LDCM. So we encourage you then to move to LDCE and to bring this to your customers and to get approvals, right? So that we can have that solution homologated, approved, and switch towards it. There is no direct migration from LDCM to LDCE, and there is also no direct you cannot even unfortunately migrate LDCM to LDCM from 226 to 227 because we have changed something on our interfaces. That's one something on the this unfortunate side. So some manual work has to be done there to adjust it for the first projects, but the interfaces are really intuitive and simple, so that should work fine. And if needed, you can also combine LDC and LDCM in the same device. That's also fine. Then for the digital substation part, the redundant merging units that I discussed in the introduction part, that's actually this analog switch. So what it does in this bumpless way. It's not seamless because it's not 0 seconds. It can switch between different analog sources, right? For example, if you have two merging units in the same bay, the main one and the backup one, if the main one fails for whatever reasons, the 670.227 ID can switch to the backup one. It can then it will make sure that all the old files, the samples that are in the filters and the buffers are cleaned out, and that the new ones are taken in and then fed to the application, right? So this takes around 40 milliseconds. So it's not, as I said, seamless, but the keys here is safety of the operation and yeah, basically reliability, security, that there is no maloperation due to this, right? It can be used for yeah, the original idea is for the samples for 69-9 or for 9-2, but you can also combine it with regular hardwired measurements. And then secure MMS is also available. The certificates shall be deployed from PCM 600. So there is no PKI, public key infrastructure supported, at least not yet. I mean, so there is also that manual part of work that has to be done, but according to our own Hitachi Energy policy and also following some of the specifications of the customers, this is a secure solution. So we now fulfill it as such. So it's encrypted with TLS, and certificates can be generated in, for example, SDM 600 or yeah, in any other such tool. Then further on digital substation, so this 69-9 part, I mentioned previously for one of the questions that there are certain limitations here. The main limitation is that the profile that is used is for currents 4 voltages only, so we don't support any further flexibility than this. We are already looking into this for the next release already, because we have received the signals from the market that this is not sufficient. So yeah, if we'll be able to enter all the markets that require it, obviously not, but we are working on this to see how much more flexibility we can stretch. So the flexibility on defining the data set, only currents, only voltages, for example, and how much we can stretch it with regards to number of channels supported. But as such, we have it. We have the level A certification as well, and then it can be mixed with yeah, the different other protocols. That is measurement methods from the ID. So you can combine in the same ID 9-2 LE and 69-9, and also you can mix them up with analog hardwire measurements. Okay, then on the packaging side, we have also made certain adjustments, improvements. So we have mainly, if you look on this left column here, we added several different functionalities into several different product types. The details around which you can check in the release notes and in the product guide. And then on the base software, that is on this 61850 Goose part, we have improved further Goose quality handling so that it can the so far behavior for the quality, when it was questionable for the Goose, the value was forced to 0, whereas now you can choose to keep this value as is while quality is questionable. And then on RER offering, we extended the number of Goose receive function blocks that certain customers requested. On the hardware part, we didn't change any hardware bringing like new stuff in, but we just change on the packaging here. We enable one more TRM in REC 670 pre-configs. Previously, it was available only as in customized. And then on the end of life part, we on top of this LDCM situation that I mentioned. By the way, on LDCMs we have end of life on medium range and long range. Short range is not affected, right? So if there are customers that need communication through MPLS network in the meantime or SDH network, then that they can use short range. Then two more modules affected are GTM for GPS time synchronization and galvanic communication module for line data. There has been very low market need for these modules, and then we communicated with the hubs and agreed that okay, we can remove them from 2 to 7 offering. We still have them on the stock, of course, to provide them as spare modules if needed, and then to provide them also in 2 to 6 and earlier. On the tool, so PCM as usual, PCM 600 with its known work methodology is there for 2 to 7 as well. Version 3.1 is needed, so respect 2, right? And this can be found of course in software library, and then the rest of the stuff you can find in the update manager, right? The conpex and ID modules. There are several improvements that we brought with PCM 3.1. They are listed here, and then more details on them you can check, of course, in the recorded webinar that is available on our Tech Talks. Few more improvements that we are bringing with Service Pack 2 is what you can see here, the certification mapping. So this is mainly for secure MMS, but then it can also be it will also be useful in future for other protocols. And then the handling of several SMTP sources in the same project, and then service pack restriction of usage of older service pack versions. On the materials, so all these, so these are external certifications. They are available on the website. You see level A covering edition 2, edition 2.1. Edition 2.1 includes also certification for 69-9. And then on the right-hand side, you can see this part for offshore applications, where 6070 series is now first also in the world on transmission level IDs that has offshore certification. So if you have customers with this need, you can present these certificates for them as additional edge and additional benefit then on our side as well. On other resources, of course, documentation has been updated. We of course added descriptions of the new functionalities, and I would really point you to read about these. For example, they're really crisp and clear descriptions of model-based, of the smart adaptive auto reclosing. There's also a description of LDC supported topologies in technical and application manuals. In application manual, we also added a description on CPU load optimization. There has been certain challenging situations with some customers that noticed that the CPU load went quite high up. Now, we explain here what is the background idea of packaging of 670 devices, and if a higher load is noticed, what steps can be done to bring it back down to optimize it. Release notes then cover everything I have been talking about and additional stuff, such as bug fixes and other improvements. And then on sales support portal, as usual, you can find supporting materials. Here now we have sales presentation updated, sample specs updated, and soon we'll also have there the data sheets. One issue popped up with regards to adding the model based in the order code because not really the issue, but the nature of the order codes as we have them today is when you add new category, like we added now for model based, is that order codes from previous versions are no longer compatible with the new ones, so you cannot just copy paste them. So there is this one additional position for model based protection, which is available in RED customized, so all customized order codes are affected by this. So to help with this situation, we created one simple migration tool where you can insert your older order code of customized product, and then the Excel sheet will return you the migrated equal to 7 order code, and this will be shared with you as well. So let's then check if we have a few more minutes for Q&A. Maybe because I have an issue here with checking the questions, so maybe I can do like this and check the questions right away here. I hope that's fine. Let's see. So I'll just scroll through like this. So Mayoa is asking, I believe the GPG is doing a good job technically by plugging the gaps in the product. How are we approaching the ease of ordering, backward compatibility and version control, especially for system integrators and third parties who are doing business in loose products, making sure we don't only have a good product, but it is also easier to configure. Yeah, I mean, this is something that we are mainly addressing in the next generation, because the order codes are structured as they are, so we have all this historic inertia carrying with us. With this simple tool that we created now for this concrete project, we hope we can help at least with migrating the order codes, but to simplify them, that's really for the next generation. From Girish, is the inclusion of RGoose or secure RGoose anticipated in the future? Not yet, not at this point. There was some chat about this, but standardization hasn't been completed to last that I heard. Yeah, but we are looking into this. From Arne, regarding LDCE, fiber is in many cases a limited source, and customers are asking for the possibility to use CWDM filter. Any plans for SFPs for this purpose? Available in the company? Okay, I'm not sure about this, so I have to check with the colleagues from NSD then about this one. So anyway, all these questions we will come back, of course, in post-webinar in the following days. I will answer them, and then you will get them written. From Manimaran, 227 function block execution order number will arrange automatically in order, or is it fixed? It is fixed, and this automatic execution we have in the next generation IDs 3.x. So in 2.2 it's fixed. And then from Andre, let's see, can the LDCE card communicate with the old LDCM card? No, so LDCE is purely Ethernet. So you need, this is the thing, so for this compatibility, to use LDCE, you need to have 227 box on one side and 227 or newer, right, in the future when we have something newer on the other side. So it's needed to have LDCs basically, because that's the Ethernet technology. From Baravadaj, is there plan to work on negative sequence differential? Oh yeah, okay. We have a longer term plan on this one. Actually, just this morning I chatted with R&D on this topic. So probably for the next generation, but yes, we have a plan for this. And then from Jonathan, this was answered. Let's see if we have something more up there. From Mura Lindharan, do we have any roadmap for virtual ID? We don't have a roadmap, but we have plans. And currently we are collecting, soliciting the requirements. So we are talking with the customers. If maybe good opportunity for any of you, when you talk to your customers, if there are any concrete requirements, ideas that they have, you can share with us in the product management so that we can take them further. But yes, we do have plans, but what we see here is that it's not really, the markets are not aligned. There is no standardization, and it's a bit tricky to understand what the customers want when they say digital twin or virtual ID. So here for the virtualization part, that's also something that we will be considering in the longer run, but no concrete roadmap as of yet. Okay, I think that has been all. So as far as I can see here, yes. So then, okay, there's something coming in. So for the increased number of CSWI blocks, yeah, I mean, you can come back to me with a concrete case, what product for which application, and so we can check that if that can be done then in the future. All right, so I would say then thanks from my side. I hope that now you have more clarity on this new 670.227 packaging, and yeah, any questions, reach out either to me or to the teams, and thanks one more time. So Durdas, then over to you.
Yeah.
Maybe I can bring up the slide again with the QR code.
Yeah, thank you very much. Thank you, Marco, for such a wonderful presentation. I'd like to thank you, everyone that has been attending. And as usual, if you could take the survey, that'll be brilliant. We will be sharing the documents in the next coming days as well. Thank you, and I hope to see you soon. Thank you very much. Bye-bye for now, and have a wonderful weekend, everyone.
Thank you. Bye.